In this video, we're going to talk about the normal curve. And this is going to piggyback on the video on z-scores, because we're going to, at the end of talking about the normal curve, we're going to start getting a sense of how z-scores can be applied to the normal curve to start understanding the percentage of scores that fall within specific z-scores. The normal curve is a theoretical distribution, and the idea is that most variables in nature follow the normal curve due to random variability, so random error. So let's first draw the normal curve. You've probably also seen this referred to as the bell curve. What this curve is telling us is that when we study something in nature, overall, if we study it an infinite amount of times, there's going to be a common measurement we get, which we know would be the mean, and then it's going to vary some, but that variability is going to fall off. So let's consider our drive into campus every day. So for me, I drive from Davis to Sacramento. My commute is roughly around 40 minutes, okay? So here, let me just put a mean of 40. And here we're talking about minutes. Now, sometimes if there's no traffic, for example, when I have to drive in at 6:30 in the morning, I get here in about 22 minutes. So let's just put here, without any traffic at all, I can get here in 22 minutes. Now, on Friday afternoons, if I'm commuting back to Davis, it takes me like an hour and 15 minutes. So that would be 75 minutes. So one thing you can see is that as I am driving in, there's some variation in the amount of time it takes me to go between Davis and Sacramento and Davis, okay? If I were to keep a log of how long it took me to commute in and get home every day for the 5 years I've been here, we would have a huge data set. And what you would see is if you put those into a frequency plot, you would see that they start taking on this shape, this very normal shape where you have an average and then there's some variability that's limited. So hopefully in that example, you can see how in your own time of commuting to and from campus, that there is an average rate it takes you, or an average amount of time it takes you to get to campus, and then there's variability based on things that are not always possible to control. The main thing is that in the long run, everything balances out. Those really fast days are balanced out by those slow days, and you have some variability around a mean. The larger sample you take, the closer the distribution looks like a normal curve. So for example, if I just wanted to take the driving I did this week, I would have 22 minutes, 25 minutes. Yes, I come to campus very early in the morning. 27 minutes. It rained one day. It ended up taking me 32 minutes. And then I also recorded my times home. And those ended up being 48 minutes, 40 minutes, 42 minutes, and 38 minutes. What we would do is we would start to plot these into a histogram, into a frequency, a graph that graphs the frequency of each of these times. And you could see with just 8 samples, you would have a distribution that looked not quite as smooth as a normal curve. So here, we have 10, 20, 30, 40, and 50, okay? And so we start getting these plots that start looking like, let's just say that we're doing intervals of 5 here. So we get some that look like this, 2, 1, we have 1 over here, oh, 2 over here, sorry about that, and then 1 and then 2. Okay, so right now the main point here is that this distribution does not look like that distribution. But as we continue to track and take this data day after day after day over a 5-year period, now it starts to take on the shape of a normal curve. And that is due to the central limit theorem that we'll talk more about as we go through this semester. The main thing to know for now is that the normal curve and the normal distribution is a standard shape. And because it's standard, it allows us to know exactly the percentage of scores that fall above the mean, below the mean, and also at any point within this curve. So what we do know, and we're going to label this as 0 because it is the mean, okay? And then we're going to put our standard deviations. And this is not a perfect drawing, so forgive me. What we do know is that within one standard deviation of the mean, 34% of scores fall within this area. So 34 here and 34 here. We also know that an additional 14% of scores falls in between the first standard deviation and the second standard deviation. And that is true on both sides of this normal curve. And then finally, in that tail, that last third deviation is the remaining 2%. Knowing this allows us to start asking what percentage of scores are within one standard deviation. So this is plus and minus one standard deviation, and that would be 68%. And within 2 standard deviations, so this would be plus and minus 2 standard deviations, is 96% of the scores. And this is going to be important for us as we come back and talk about how the z-score relates to the normal distribution in class.